So this is the final of the videos for this simulation update. So what you can see here is my final SIMD version of the simulation running. So first thing, draw 30-40 microseconds, pretty quick. Texture buffer update, a lot quicker. It's still one of the slow bottlenecks, and also the update going on here, but look how many particles I've got there. There's a lot of processing and drawing and everything else going on, so much so that it's really hard to actually delve down and see exactly what is going on in this code here. There's just such a dense amount, but you can see I'm getting full interactive workloads going on, which is really nice. You can most probably hear the fan of my computer in the background. You can also see that I am maxing out all of my cores nicely, so I'm doing a lot of really good work going on here. You can see, average CPU load is getting up there in the 70s now, which is really, really nice. I'm pretty much hammering a lot of my memory as well, because there's a lot of data there. It's not too bad actually. So this is pretty good. This is doing a lot of work. It's doing a lot of really useful stuff here. Let's just run it with a few less. It takes a while for this to sort of fire up, so let's just run it with a few less, and we can really see how efficient this is. Now, one of the things that the efficiency and everything else sort of does take away from us is that we begin to lose some of the clarity in the code and the niceness in the code. So this code is beginning to look pretty non-standard, I should say, for what you would normally be taught as proper OO design and things like this. But it's very much standard for if you look inside game engines and other sort of DCC tools and things like this, because this is all about getting the best out of the hardware. So first thing now is I've got a template class here called aligned array. All this does is it makes a call to mmmalloc, which is part of the SIMD library, the intrinsics library. This allows us to allocate memory with correct alignment. So it's actually calling aligned malloc and a few other things. Now C++ 17 does have a version of new which does an aligned version as well. So I did put this note in there to update this when I wrote it a few years ago, and I've just not got around to doing it. But this is basically, it's a sort of it's using the principles of RAII, resource acquisition is instantiation. So when this is constructed, it allocates a chunk of memory here on the heap, and when this object is destroyed, it automatically calls the destructor and frees things up. There's this reset method here which will redo the alloc and the malloc. So basically I'm using this a bit like a unique pointer, but it's a unique array of data, but it ensures it has this alignment which will just make sure things go a lot faster. The other thing I've got here, which are all part of my SIMD lectures, and this code comes from a bigger chunk of code that was written by one of my old colleagues, and it's also used in several open source libraries, or elements of this are. And it's just to make the SIMD instructions a bit more human readable. So the data types are sort of defined as F256, so it's a float 8, it's an F256 rather than the double M underscore, so on. Set 4F will set 4 floats, set 8F, and so on. So this just makes the code a bit nicer. Splat will set all of the registers to a certain value, and you can see there's various bits and pieces here, mal 8F, add 8F, just to make the code a bit nicer, a bit easier to read, and so on. And so now grid, and this is where the big majority of the changes have come. I've got rid of that ill thought out Vec 3x8 class. I mean, it really was such a stumbling block, that class. And instead I've got, for my x's, an aligned array, for my z's, an aligned array, my x and my z aligned array. So I'm doing it in 2D now. I've just got rid of the 0 component, it doesn't matter. And I've got my array for acceleration and my array for max speed. Everything else in here is more or less the same, but you will notice now my texture buffer objects have now also been split. So I've got 4 texture buffer objects. Basically what I'm going to do is I'm going to load to the shader my X, my Z for position, X and Z for my buffer. And if we have a look at the vertex shader now, you can see that I've got 4 samplers now. So I'm basically going to have a buffer for the X's, buffer for the Z's in both of them, and I construct my input position by texel fetching the X sampler, the Z sampler, that sampler and that sampler. And the reason I've done this is because I'm creating my texture buffers now. I can actually directly blit the SIMD values to it, as we'll have a quick look at that next. So here I'm sorry, let's go and generate my texture buffer first. So create texture buffer. So here I'm creating 4 buffers. Each one of these is the number of particles multiplied by the size of a SIMD register. So a WM256 or a float 8. And you'll notice now I'm packing this data as just an R32F, so a single floating point value. So this data is just being concatenated together as a series of floats, which I'm then reading one at a time as I go through. And I'm doing one for the X, one for the Z, dir X and dir Z there. So when I update my texture buffers now, each time all I'm doing is saying buffer data, number of particles times the size of this, and I'm passing in directly that aligned array register, all aligned there. So this is incredibly quick. It's far faster than the previous versions I had. Only other real changes to this is obviously just the way the code is laid out. So I reset, still rounding to 8s, reset all of my data here each time. So this is going through and resetting everything as I go through to resize the arrays. And then when I generate my particles, now I'm just going through and making a call to my, sorry, that was update. What I wanted to do is reset. So I've still got my random number generators I had before. Notice I've changed them to now use the load 8F rather than the intrinsics built in. So we're just doing the individual components each time. So all the X's get set, all the Z's get set in their own way, and the max speed and acceleration. The update particle is slightly less instructions now because I'm just doing direct multiply dir X by acceleration by dt. So I've combined that together into one operation. I don't really, there is most probably a further thing that I could do here, that I could do some form of fuse, multiply and add perhaps, but I don't think it would make much difference. Here's my clamp as a function, and then I clamp my speed values there for direct X and Y. And then my check bounds and update, again very similar from before, that I have to drop into single SIMD lanes for bounds and things like that. So I check to see whether my update's needed if I reset, or whether everything needs resetting. Again, those are the two easy cases, and then I drop down to non-SIMD mode to just update the individuals and then do the lane sets. Again, this is slightly more efficient now because I'm only having to load the individual lanes and so on. Again, there are a few maybe tinier bits of optimization that I could put in here, but as you can see, this really does work incredibly quick, and we've gone from basically our CPU only version. Going to work for me. I seem to have lost all control of that terminal. So this version is running with draw and update with okay, there's a few particles there. Let's give it some work as well. -n. Let's give it 50,000, give it some work to do. And what we should see is that, there we go. So equivalent load, this is really, really slow. Updates taking a long time, so 34 microseconds. This is taking sort of 7,000 microseconds plus another, say 1,000, so 8,000 microseconds to 34. And draw is taking no time at all, 20-30 microseconds as opposed to this huge amount there. So we really have gone from something that's incredibly slow to something that is ridiculously fast. What next? Well, the next stage is going to be putting this simulation onto the GPU and to use compute shaders. Maybe I will also look at maybe doing it with Vulkan as well. That's going to happen in the next few weeks, so I will update these posts and add some new stuff later once I get a chance to write it all. Fortunately, I've got other work to do in the meantime, but it's been fun doing this and exploring this. I've learnt a lot. Hopefully you'll find this all useful as well.